Okay, 6.3. The key features of a quadratic relation. So we need to be able to talk about the different aspects of this parabola. Now, what is a parabola? We've talked about that. It is that U-shaped curve. It's symmetrical. And all of the ones that you've seen so far have been opening up, but it's quite possible that we can have a parabola that opens down. And they can move all over our Cartesian plane. We could have it up there. We could have it over here. You could have it over here. Those are all parabolas. Okay, so we're going to want to talk about different key features of these. Vertex, maximum, minimum, axis of symmetry, and the x-intercepts. If the coefficient of the squared term is positive, the parabola opens up, and you're going to have a minimum value. And if the coefficient of the squared term is negative, then the parabola opens down, and you have a minimum. When they talk about the coefficient, they're talking about the a value. So if you have y equals a negative number, oh no, sorry, a positive number is what we started with here, then what you have is it opens up. That's the first important thing. If you have y equals a negative x squared, then it's going to open down. So let's talk about a few things, and then we'll go back and reread this, and it'll make sense. So here is a parabola. There it is there. Here is a parabola. There it is there. Here is a parabola. There it is there. The coordinates of its vertex. What are its vertex? Well, I'm going to tell you right now, that's a vertex, that's a vertex, that's a vertex. So this has a vertex of 3, negative 1. This has a vertex of 2, 1. This has a vertex of 0, 4. So this one is 3, negative 1, 2, 1, and 0, 4. So what is a vertex? The point at which the parabola changes direction. So the parabola is decreasing, 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 then increasing, 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 increasing. And we always read left to right. So moving left to right, it's increasing, 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 increasing till it hits the vertex, then it's decreasing. Reading left to right, it's decreasing, 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 then increasing, 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 reading left to right. Those are the vertexes. The equation of the axis of symmetry. All right. The equation of the axis of symmetry on this one is here. On this one is here. On this one is here. So the equation is given by x equals 3. This one is x equals 2. And this one is x equals 4. And those are the axes, can't spell, axis of symmetry. Axis of symmetry, axis of symmetry. Okay? So what does that mean? That is the vertical line that cuts right through, I'm a little bit off on this one, that is the vertical line that cuts right through the parabola so that there's half of the parabola on one side and half on the other side. It's called symmetrical because if I was to fold it over that line, it would line right upon the, so this arm, if I folded it, would lie right on this arm. So they're symmetrical. They're the same shape and same size on either side. The axis of symmetry, you'll see, goes right through the vertex. And it is, in fact, the axis, its equation is equal to the x value of the vertex. And that kind of makes sense because if it's a vertical line, which we've said it needs to be, if it's a vertical line, then its equation is x equals, and every single point on that line has the same x value. Well, since the vertex lies on that line, then we can use that x value of the vertex for the equation of the axis of symmetry. Did I say it had a vertical axis of symmetry of 4? Very wrong here. 0. sorry, this has a vertical axis of 0. It's 0, comma 4. That was the y value that I did there. I'm sorry, that was a little bit too quick. Should have slowed down there. So this is definitely an axis of symmetry of x equals 0. This one's x equals 2. This one's x equals 3. All of these points have the same x value of 2. Y-intercept. Well, the y-intercept is going to be where it's going to be crossing the y-axis, of course. So this one over here has a value of 8. This one over here has a value of -3. And this one over here has a value of 4. So the y-intercept here is 8 and -3 and 4. Now those coordinates, remember, are different. The coordinates would be 0, 8. The coordinates here will be 0, -3. And the coordinates here will be 0, 4. So its vertex is also its y-intercept in this case. Maximum value or minimum value. So that's the largest y value that the function will occur. So we look here, it keeps going up and keeps going up. There is no maximum value. It keeps getting greater and greater. But there is a minimum value. There's a smallest value that it can hit. And that's right there. That's a minimum. Now notice a minimum occurs when the parabola opens up. Because if it opens up, there is going to be no maximum. It's going to keep going. So it has a minimum value of y equals -1. Now this parabola opens down. So there's no minimum value. It's going to keep going down and down and down. But it definitely has a maximum value. It goes up and up and up and up and up until it hits 1. And then it goes down, 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 reading left to right. So this has a maximum value of y equals 1. So this is a minimum. This is a maximum. Next one. Opens up. So it's going to have a minimum. And its minimum is 4. Okay. So looking up here. Maximum or minimum. It's the greatest or least y value on the graph. And it's from the y value of the vertex. So if you find the vertex, you not only know the axis of symmetry, which is the x value, but you then know the maximum or minimum value. Now, you don't know whether it opens up or down with just the vertex. You got to look at the a value, the value in front of the x squared. Next, x-intercepts. Well, the x-intercepts are right here. I need another color. I've got an x-intercept here and here for this one. I've got an x-intercept here and here for this one. And this one, I have no x-intercepts. So it's possible not to have any. In this one, we have x-intercepts of x equals 2 and 4, which means it's going to cross at 2, 0 and at 4, 0. This one has two x-intercepts, x equals 1 and 3, which means it's going to cross at 1, 0 and 3, 0. And this one has no x-intercepts. It opens up, and its vertex, its lowest value, is above the x-axis. So if its lowest value is above the x-axis and it opens up, it's not going to cross the x-axis. So it's possible to have two x-intercepts. It's possible to have no x-intercepts. And what I don't have on here is an example where it would have no x-intercept. So let's take a look. Or sorry, where it would have one x-intercept. So there is an example where it's going to have two x-intercepts. Here's an example where it will have no x-intercepts. And here's an example where it could have exactly one x-intercept, where the vertex lied on the x-axis. So you could have two, you could have none, or you can have one. All of them are possible. And don't make any mistake, remember we could also be opening down. Whether we open up or down doesn't really matter. The only thing that's happening here is that you have a negative in front of the x squared. In this one you have a negative in front of the x squared. In this one you have a negative in front of the x squared. In these ones you have a positive in front of the x squared. You have a positive in front of the x squared. and a positive in front of the x squared.